We have investigated the field inside a large circular loop. Since a compass will always point in the direction of the net magnetic field at its location, we can use it to indicate the net field at the center of our loop. The net field there depends on the contribution of the loop's field and Earth's. This is actually the horizontal component of Earth's field. We had a laboratory experiment entitled the tangent galvanometer. The materials needed in the experiment the tangent galvanometer are 1-piece tangent galvanometer, 1-piece compass, 1-piece power supply, 3 pieces banana connectors, 1-piece ammeter. We will have 4 sets in our experiment. The first one is the direction of the magnetic field at the center of a current loop. Second, magnetic field in a loop with varying number of loops. The third one is magnetic field in a loop with varying current. And lastly, determining the horizontal component of the Earth's magnetic field. In the direction of the magnetic field at the center of a current loop, first, set the number of loops fixed at 5 and the current fixed at 1A. When the power is turned on, begin with the power turned off. Be sure to turn the power off when you're not making measurements. Verify that the loop's field at its center is normal to the plane of the loop. Orient the loop so that its label is facing north. Turn on the current and describe what happens to the needle in the compass. Now rotate the loop with the label facing south. Turn on the current and describe what happens to the needle in the compass. Now, set up the loop so that the label is facing east. Turn on the current and describe what happens to the needle in the compass. Note the direction of the net magnetic field vector and graphically show the vector addition. B net equals B loop plus B earth. In magnetic field in a loop with varying number of loops, first is keeping the label of the loop facing east, the number of loops 5, and the current 1 ampere in the setup. Note the angle where the needle of the compass points. You need to read the compass as accurately as possible. Record your results in table 6b. Change the number of loops to 10 turns and repeat the procedure. Do the same for 15 turns. Lastly, plot tangent theta versus n. In magnetic field in a loop with varying current, first is keeping the label of the loop facing east, the number of loops 5, and the current 1 ampere in the setup. Note the angle where the needle of compass points. You need to read the compass as accurately as possible. Record your results in table C6. Change the current to 1.5 amperes and repeat the procedure. Make 5 trials with 0.5 amperes increments. Plot tangent A versus I. In determining the horizontal component of the Earth's magnetic field, first is measure the radius r of the loop. Using data from trial 3 in part B and part C, solve for B loop using equation 1. Compute corresponding B earth using equation 3. Get the percentage difference between the two values obtained. Summarize your results in table 6D. The second experiment is entitled electromagnetic induction. Electromagnetic or magnetic induction is the production of an electromotive force across an electric conductor in a changing magnetic field. Michael Faraday is generally credited with the discovery of induction in 1831, and James Clerk Maxwell mathematically described it as Faraday's law of induction. Electromagnetic induction has found many applications in technology, including electrical components such as inductors and transformers, and devices such as electric motors and generators. The materials needed in the experiment electromagnetic induction are 1-piece tangent galvanometer, 2 pieces of banana-banana connectors, 1 piece of bar magnet, and 1 piece of ammeter. Connect the oil or loop or galvanometer to the ammeter using 15 turns and examine what happens to the current when the magnet is in motion through the coil. Hold the south pole of the bar magnet with the north pole closer to the galvanometer. Observe the induced current when the magnet is A. held in place, B. moved toward the galvanometer, C. moved toward the galvanometer. Now hold the north pole of the bar magnet with the south pole closer to the galvanometer. Observe the induced current when the magnet is A. held in place, B. moved toward the galvanometer, C. moved toward the galvanometer. Repeat steps 2 and 3, but doing them faster. Repeat all steps using 10 or 5 turns in the galvanometer loops.